This is a continuation on the absorber and stripping columns. Let's look at an absorber that no longer has pure liquid coming in. So we no longer know what the liquid is coming in. We cannot assume that it is clean. So maybe it's contaminated with some amount, and that's maybe, I don't know, some amount like 0.001 moles per hour or whatever, some very small amount. But it will no longer be able to strip the vapor to purity or to a pure state. Before we said before before we said you could get the contaminant coming out with the vapor to equal the contaminant that was going into the going in with the vapor times the recovery fraction of the absorber. But now that we have contaminant coming in with the liquid, we have to add that in. So L naught times 1 minus the recovery of the absorber if it was a stripper. And that's actually what we get. So you just plug in these, you just plug this in. So this is, again, you just plug that in right there, and you plug that L naught up here. It's the same right there. Same thing. And again, if you can calculate A, you know A is 1 over S, or that S is equal to 1 over A, and that the recovery fraction is equal to SE minus 1 over SEN plus 1 minus 1, and for the stripper recovery fraction, and the recovery fraction for an absorber is equal to AE minus 1 AEN plus 1 minus 1. And remember, AE is when you assume that A1 is equal to A2 is equal to A3, and so on and so on. And that's off the assumption that based off of the assumption that L, the total flow rate of the liquid, does not change through each stage. So L in the top, L going into the top is the same as L coming out. So the flow rate of the liquid into the column is equal to the flow rate of the liquid out of the column. You assume that it doesn't absorb a lot of fluid or anything. It doesn't absorb a lot. And you also assume that the vapor flow rate is the same going into the column as it's leaving the column. So you have to assume that very little or the amount of contaminant leaving the vapor phase is minor in comparison to the total vapor flow rate. But that is how you calculate VN1. Now let's say for strippers, it's the same idea. It's L1 is equal to Ln plus 1 times the recovery fraction, or the stripping recovery fraction, plus V naught, so assuming that there is some type of contaminant in the vapor coming into the stripper, times 1 minus A. So that is how you calculate how well you can, or how low you can get this value. How low can you get it if you have a clean, or if you don't have a clean stripping agent